Okay, it's 9 p.m. now. Oh, sorry, 9 a.m. now. Okay, we start the class. So, your friend may be late. Okay. Before we start the class, let me make some agreement with you. Okay? Okay, the first agreement is please don't make noise. Okay? Because it may disrupt me and including your friend, and it make me finish the class late. Okay, and second, if you have any question, please feel free to ask. And the third, I may pick some lucky number of you to answer the question during the class. Okay? First topic is influenza virus. And some of you may know about this virus. Do you get vaccination with this influenza vaccine this year? Get vaccination? Yes? Okay. Normally we should get the vaccination with influenza vaccine every year because the virus have the high variation and the immunization every year may protect ourselves from the infection of this virus. The report from CDC and WHO in recent years show that there are 28 influenza-associated pediatric deaths have been confirmed in the USA during this flu season. And in our country, the flu influenza virus occur every year too. So we have to know about this because you are the person that may work in the medical care and have a chance to expose the patient with influenza virus infection. And this is the objectives for this lecture. Influenza virus is classified into the orthomyxoviridae family, and the particles are pleomorphic, but usually spherical and about 100 nanometer in diameter, which vary from 80 to 120 nanometer in diameter. The genome of the virus is single-stranded negative RNA with segmented. Some of the virus in this family have 7 segment RNA molecule, but some have 8 RNA molecule, which I will mention about this later. The genome envelope, the RNA genome is encapsulated and covered with the lipid bilayer envelope here. At the envelope, there are 2 important types of protein molecule that spike through the envelope, which are hemagglutinin and neuraminidase proteins. Okay, this is the ratio diagram about the virus in this family, which show the ribonucleoprotein in size and the double layer envelope and neuraminidase and hemagglutinin spike protein. Here, okay, as I mentioned that the RNA molecule is segmented for 7 to 8 segments, and the important RNA molecule that encode for the proteins are HA, or that encode the production of hemagglutinin protein. This protein function as the mediates virus attachment to cells. Next is neuraminidase or NA. This virus function as about the viral release from infected cells. And the PP2, PP1, and PA. These three proteins form the RNA polymerase complex that function for the RNA synthesis while the viral replication in the cells. There are 4 types of seasonal influenza virus. Okay, which are influenza A virus, influenza B, C, and D virus, but only 3 group of influenza virus, which are A, B, and C, infect humans. Influenza D viruses primarily affect cattle and are not known to infect and cause illness in people. Influenza A virus, which is the most circulating strain in humans. It can also infect some types of animals too, and I will mention about it later. Influenza A virus are further classified into subtypes according to the combination of the hemagglutinin or HA and neuraminidase or NA. And currently circulating in human are subtype A, H1N1, and A, H3N2. Influenza B virus also cause the infection in human. The current circulating influenza B virus belong to either B Yamagata or B Victoria lineage. But influenza B virus is not classified as subtype, unlike influenza A. Okay, and influenza C virus is detected less frequently and usually cause mild infections. The seasonal influenza vaccine that are available in recent years contain influenza A and influenza B virus, but did not contain influenza C virus. Okay. And I said that there are three subtypes of there are three types of influenza A that circulate in human, which are A, B, and C, and this shows some differentiation of each strain. Influenza A and B contain 8 RNA segments genome, while the influenza C contains only 7. This type, influenza C, lack of neuraminidase. Influenza A virus can cause the infection in several host range, which are humans, swine, which is pig, avians with its birds, equines with its horse, marine mammals, and bats. Influenza A virus had unique integral membrane protein named M2 ion channel protein, and the unique protein for influenza B is NB. NB is believed to function like M2 protein in influenza A virus, which is the ion channel proteins. While influenza C contains unique protein, which is HEF or hematoprotein esterase fusion. The disease severity of influenza virus is often severe, while influenza B occasionally severe and influenza C usually mild. Okay, for the nomenclature of the influenza virus, the standard nomenclature system for influenza virus isolates include types, which is A, B, or C, host of origin, such as avian or swine, but host of origin is not indicated for human isolate. And the example of the nomenclature will be shown in the next slide. Next is geographic origin and strain number and the year of isolation. For influenza A virus, the antigenic description of the HA and NA should be given, while influenza B and C should not. Okay, this is the example of the nomenclature of the influenza virus. The first example, this is the influenza A virus, okay, that isolates from swine. And the geographic origin is Iowa, strain number 15, and the year of isolation is 1930. Since this is the influenza A virus, so this must indicate the H and N number. Actually, there are about 18 H subtype and 11 N subtype has been detected right now. And the second example is influenza A virus. And since this virus is isolated from human, so the host of origin should not be indicated. And the geographic origin is Hong Kong. Okay, and the strain of this influenza A virus is H3N2. And this table shows the composition of influenza A vaccines that compose of influenza A and influenza B virus, as I already mentioned. For the replication of the influenza virus in host cells, influenza virus will bind to the cell receptor of the host cells. The receptor is cyclic acid. There are two types of cyclic acid receptor that indicate, which are cyclic alpha 2,3 galactose linkage. Another is cyclic 2,6 galactose linkage. And these receptors are found in different cell types, such as in the upper respiratory tract of human. The cyclic type receptor is SA26 galactose linkage, while in the avian cells, the receptor is alpha 2,3 galactose linkage, and the detail about this will explain more in detail in the next few slides. Okay. After the binding of the receptor, the binding of the virus to the cell receptor, the virus uses hemagglutinin or HA to bind to the cyclic acid receptor. Then the virus is released into the cell and release the RNA nucleocapsid into the nucleus. The replication of the influenza virus occurs in the nucleus. Some of the steps occur in the nucleus and some occur in the cytoplasm, which difference from the virus in the next topic, which are mumps, measles, and rubella that replicate in the cytoplasm. Okay. And I will not go into deep detail about the replication cycle of the influenza virus. The important thing that you need to know is that once the RNA nucleocapsid is released into the nucleus, since the genome of the virus is negative single-strand RNA, and the virus contains RNA-dependent RNA polymerase, the virus have to use the cap primer sequence from host cell, which called cap snatching. This occurs via the endonuclease activity of the PB1 protein of the virus. Okay. Next step, the viral mRNA is translated. The early products of the translation is NP and PB1 proteins, and RNA polymerase activity of the PB1 protein synthesize positive single-strand RNA intermediate from the genomic negative single-strand RNA molecule. RNA polymerase activity of the PB1 protein synthesize new copy of the genome using the RNA intermediate as the template. Okay, and some of these new genome segments serve as template for the synthesis of more viral mRNA. Later in the infection, they will become progenitive genome. And Viral mRNA molecule transcribed from other genome segments encode structural proteins such as HA and NA, and these messages are translated by ER-associated ribosome and delivered to the cell membrane. Viral genome segments are packed as protein virion and bud from the host cells. During the viral replication in the cells, there are some mutations occur spontaneously because the RNA polymerase of the virus do not have proof leading activity. So the mutation occur. The spontaneous mutation occur called antigenic drift, and this can cause the change of the neuraminidase or hemagglutinin proteins of the virus and cause the new mutant virus. Sometimes the mutation occur like not a major mutation but minor mutation, but it may develop several mutations cycle and cause the mutated virus. Another change with the virus called antigenic shift or reassortment. Antigenic shift occur when two strains of the virus co-infect in the same cells. And during the replication, two strains of virus may cause the reassortment of the RNA segment. So, and this can generate the new strain of the virus. Okay, this is the more detail about antigenic drift. Antigenic drift can involve either HA and NA proteins as well as the gene encoding other structural and non-structural proteins. And these mutations are caused by viral RNA polymerase enzyme because it lacks proof reading activity like I already mentioned. Antibody against the original virus become progressively less effective. So, okay, for the next is antigenic shift, and please correct the text in this slide that I already give you. It is the same as the previous slides. Okay, for antigenic shift, it occurs abruptly and unpredictably, and only influenza A virus undergoes antigenic shift. Because type B and C are restricted to human, but influenza A circulates in other animals such as birds,